exploring unknown tech, decoding future unicorns. Welcome to Product X, using the sharp intuition of capital and the hardcore logic of an architect to help you catch the next big event in the global tech sphere. Hello everyone, I'm Rena. If you run an e-commerce website, AWS and Azure are perfectly fine. But here's the uncomfortable truth. When you're training a trillion parameter model across 10,000 GPUs, the architecture designed to host your online store becomes a straitjacket. Legacy clouds impose something called a virtualization tax, thick hypervisor layers and multi-tenant isolation that turns microsecond-level latency into a nightmare. The entire AI world is starving for compute, and the old giants are failing them. Today, we're diving into Volta Infrastructure Holdings, a company that's betting everything on solving exactly that problem. Vivian, want to kick us off?
Hey, Rena. Hey, Nolan. Yeah, I've been watching the AI infrastructure space for years, and what Volta is attempting immediately caught my attention. Not just because of the $300 million, but because they're doing something you almost never see at the seed stage. They're building heavy asset infrastructure with venture money. That's a bold move.
Nolan, your turn.
Hey Rena, Vivian. From the technical side, I'm skeptical of anyone claiming they've solved distributed training at scale, but I will say this. Volta's focus on stripping out virtualization and going bare metal is exactly the right instinct. Whether they can actually execute it is another story.
So here's the question we need to answer today. Is Volta Infrastructure actually positioned to crack the compute access problem? Or is this just another well-funded dream that crashes against the wall of engineering reality? Let's dig in. First, let's ground this in real money. Vivian, who is losing right now because compute is broken, and how expensive is this problem actually getting?
Let me give you a concrete number. A mid-sized foundation model company I work with spent $40 million on cloud compute last year alone. That's not even training the biggest models. That's just running experiments and fine-tuning. They estimate they'd save about $15 million annually if they could move to a dedicated bare metal provider. Multiply that across hundreds of AI startups, and you're looking at billions left on the table. The pain is real and immediate.
The money is definitely there, but here's where I'd push back. Those savings only materialize if Volta can deliver consistent performance at scale. Legacy clouds overcharge? Sure, but they also have decades of operational maturity. A startup with a few thousand GPUs might not have the same reliability. You're not just paying for compute, you're paying for uptime.
That's fair, but I think you're underestimating what the NVIDIA partnership actually gives them. NCP status isn't just a marketing badge. It means priority access to the latest chips, which in today's market is worth its weight in gold. The allocation rights themselves are a form of collateral that Wall Street funds are willing to lend against. That's the real moat.
Allocation rights today, maybe scarcity tomorrow. NVIDIA could change partner tiers next year. The hardware advantage is fragile if it's just about getting chips first.
Okay, so the problem is expensive, we've established that. Now let's go to the core mechanism. Nolan, you mentioned bare metal and stripping out virtualization. Walk us through what Volta is actually building, technically, and why it matters for training at that scale.
Here's the simplest way to think about it. In legacy clouds, when GPU A needs to talk to GPU B on a different server, the data path goes like this. GPU to CPU to operating system kernel to the network card, then across the network, then reverse the whole thing. Every hop adds latency. In distributed training, all reduce operations, where every GPU synchronizes gradients. Happen thousands of times per training step. If your network latency jitters, the whole cluster stalls waiting for the slowest node.
And Volta's approach fixes that how?
They use something called GPU direct RDMA. The data goes straight from one GPU's VRAM through the network card into the other GPU's VRAM, completely bypassing the CPU and kernel. That alone can cut end-to-end latency by orders of magnitude. Then they build a non-blocking fat tree topology using InfiniBand switches. What that means in practice is that no matter which two machines are communicating, they get full bandwidth. No congestion, no stragglers. For a 10,000 GPU cluster, that's the difference between training that actually scales and a very expensive space heater.
That's a compelling technical story, no question. But I want to challenge the assumption that bare metal automatically means better performance. I've seen startups deploy custom infrastructure that looked amazing on paper and then ran into operational nightmares. Who's actually running this? Do they have the team to maintain that level of network engineering day in and day out?
That's the real question. The architecture is sound, but architecture doesn't ship products. People do. And honestly, at $300 million, they can afford to hire the talent. The bigger risk is whether the operational maturity catches up to the ambition before something breaks in production.
Let's talk business model. Vivian, who actually pays Volta? And is this structurally a business that gets cheaper as it scales?
The customer base is pretty clear. Foundation model companies, AI research labs, anyone training large models. They're not going after web hosting. They're going after the compute-heavy workloads that AWS and Azure are poorly optimized for. The pricing is typically 30 to 50% below legacy cloud TCO when you factor in the actual compute you get.
And does more usage make the product better?
It should, for two reasons. First, larger clusters mean they can negotiate better terms with NVIDIA. More chips, better pricing. Second, and this is key, Volta owns the full stack, the hardware, the network, the cooling, the orchestration software. Every customer that runs on their infrastructure generates data that improves their scheduling algorithms. So yes, there's a learning curve that benefits from scale.
I'm less convinced on that second point. Their scheduling advantage over Kubernetes or Slurm is not obvious. Bare metal provisioning is a solved problem. It's not like they have secret sauce there. The real differentiator is the network topology, and that advantage is set at deployment time, not learned from customer usage.
I hear you, but I'd argue the integration layer matters more than you're giving credit for. When you own everything from the fiber to the firmware, you can tune for specific workloads in ways a general-purpose cloud can't. It's the difference between a race car and a sedan. Both have wheels, but one is built for speed.
Fair. But building a race car doesn't mean you can drive it at 200 miles an hour without crashing. The operational risk is real, and customers care about reliability more than theoretical performance.
Now, let's get to the counter-argument. If I wanted to prove Volta doesn't work, what's the strongest case? Vivian, you take this first.
The strongest bear case is actually pretty simple. Volta is building a capital-intensive business in a market where their primary supplier, NVIDIA, is also their closest competitor. NVIDIA is vertically integrating into cloud services themselves. If NVIDIA decides to keep more chips for their own cloud or prioritize other partners, Volta's allocation advantage evaporates overnight. They're betting their business on a relationship they don't control.
And I'd add the technical counter risk. Getting to 10,000 GPUs is one thing. Keeping a 10,000 GPU cluster running at 95% good put for months is something entirely different. Hardware failures at that scale aren't exceptional, they're routine. Every few hours something breaks. Checkpointing multi-terabyte models, handling thermal throttling, maintaining network topology under partial failures. That's an engineering challenge that has tripped up much larger teams. If Volta can't solve fault tolerance at that scale, all the bare metal optimization in the world won't save them.
That's a legitimate risk, no question. But here's where I'd push back. The companies that have solved fault tolerance at scale, and I'm thinking about what CoreWeave and Lambda have done, prove it's possible. It's hard, not impossible. And Volta's $300 million gives them the runway to hire the people who've solved this before. The capital is a weapon here, not a liability.
Capital helps, but it doesn't guarantee execution. Plenty of well-funded startups have crashed into the wall of operational reality. I'm not saying they will fail. I'm saying the engineering execution risk is being understated in this narrative.
Let's land the verdict. Vivian, what is real about Volta? What's still a bet? And what do we watch next?
What is real is that compute scarcity is a genuine problem worth billions of dollars, and Volta has the right technical thesis. Bare metal, full stack integration, NVIDIA partnership. What is still a bet is whether they can actually operate at the scale they're promising without catastrophic failures that lose customer trust. What to watch? In the next 6 months, look for announced customer deployments. Real logos, real training runs, not just press releases. That's the signal that separates talk from traction.
Nolan, your verdict?
Real. The architecture is sound and addresses a real pain point. Bet. Whether their team can execute on the operational complexity of 10,000 card clusters. Watch. Their uptime numbers. If they can publish and sustain 95+% good put on production clusters, they have a defensible business. If not, they're just another infrastructure startup with a beautiful spec sheet.
So here's my take. Volta has correctly identified that legacy clouds have a fundamental mismatch with AI training workloads. That's real and it's worth solving. But the $300 million buys them a seat at the table, not a victory. They need to prove they can deliver consistent, reliable performance at scale before this becomes anything more than a promising experiment. If they can crack the fault tolerance problem, they genuinely have a shot at becoming the infrastructure backbone for the next generation of AI. If not, all that NVIDIA allocation in the world won't save them from becoming a cautionary tale. Thanks for joining us today, Vivian, Nolan.
Thanks for having me, Rena.
Pleasure.